G'day. I know that if students are given the equation for a straight line, that many of them find great difficulty finding the equation for a line that's parallel or perpendicular. Now, in these two videos, this one and the one following, I'm going to explain how to do this in a very simple way. So, I encourage you, even if you feel you do understand the process, to have a look and see if there's not something for you, because I'm fairly confident that it's something you won't have seen. And it's faster and simpler and quite mathematically correct. I'm not going to go through a formal proof, but I will try and explain so you understand the process. Now, first of all, if we're given the equation for a straight line, quite often it's given in this format. This is called the Gradient-Intercept Form. Simply because in this format where we have y by itself on the left hand side of the equation and some coefficient times x plus some constant, the coefficient happens to be a measure of the gradient of the line and the constant is a measure of where the line intercepts the y-axis. So it's called the Gradient-Intercept Form because of these two values. Now, just to cover some very simple basics. If, for example, a line had a gradient of 2, it means that wherever it is, I suppose I should do it properly, if the intercept is at plus 3, it goes through plus 3 on the y-axis. And if it has a gradient of 2, it means for every unit that it travels horizontally, that is along the x-axis, it travels 2 units up the y-axis. What it means is, every time x grows by one value, when we try to find the y value, we have to double that growth. So every time x grows by 1, y will grow by 2. And we can go across 1 and up 2 and across 1 and up 2 and keep going like that. Now, of course, every parallel line is going to have the same gradient. Cross 1, up 2, cross 1, up 2. I'm not drawing that very well. Which means that in this format, finding the equation for a parallel line is actually quite easy. In this case, it just means it has the same gradient as that one, and this is a great big question mark. We just don't know where it is yet, but this line is parallel to that one. Now, how do we find this? There are two ways it's done traditionally. I haven't shown you my shortcut yet. It really doesn't apply quite to this expression. But the two methods are these. Let's say I chose a point. Let's say I chose the point 4, 1. There we go. There's the point 4, 1. Across 4 and up 1 unit, and I want a line parallel to this line through there. Well, if we understand what the locus of a point, or what the equation for a line gives us, it is this. Every point on this line satisfies that equation, which is why we draw the line or draw the picture, because it represents the values that make this equation true. So we're looking for an equation that will find all the points, including this one, that will make this equation true. So 4, 1 makes this true, then we can substitute it. And the way I do that, and we'll change colours, is I would substitute the value 4 and 1, or the coordinates 4 and 1, into this equation. Now, let's do this algebraically. We don't use question marks typically. We would use, here in Australia we tend to use y equals mx plus b, because this is the basic form. I believe in some other countries, I've seen some texts from the United States and one or two other countries that use a c here, mx plus c, it really doesn't matter. But if we substitute 4 for the x value and 1 for the y value, so in place of y we put a 1, in place of x we put a 4, we would solve this. 2 4s are 8. We would subtract 8 from both sides, so 8 from 1 is negative 7, and 8 from 8 is 0, just leaves a plus b, so b is negative 7. And we would, now that we know the value of the constant b, or the intercept, we put it back into the equation, and we get y equals 2x minus 7. And what it means is not just that it has a gradient of 2, but the line goes through negative 7. 1, 2, 3, 4, 5, 6, 7. And there's where it goes. So far so good. So far so good. But what if you're not given the equation in this format? This is quite easy to use. In fact, I haven't shown you the second method, so let's do that quickly. Well, here we are looking at the same equation that we started with, and we want a parallel line passing through this point. So, instead of writing y equals mx plus b or y equals 2x plus b and using that structure, since we know the gradient we want, and since we know a point on the line, we can use the point gradient formula, and some students, a lot of students, prefer this. Now, elsewhere I'm going to explain the point gradient formula, but here I'm going to assume that you know it, and it looks like this. x1 and y1 are the coordinates of this point. I'll just write that here. And the m is the gradient of the line, which we have here. So let's write the m in first. We know we want a gradient of 2. Notice you don't have to write the equation in order from left to right. With a lot of practice you do that. But sometimes it's good to do things in the order that your mind thinks. And if you want to get the gradient sorted out first, do it. Now I'm going to work on the coordinates, and I like to work with the x value first and then the y value. Now I don't always do this, I work left to right because I've done this a lot. But if I wanted to be safe, the x value is 4, so I'm going to put that here, or the x1 value at least. And the y1 value is 1, so I'm going to put a 1 here. I don't actually need the parentheses here because there's nothing in front of it. So here we would have y minus 1 is 2 times this expression. Well, 2 lots of x is 2x, 2 lots of negative 4 is negative 8. If I add 1 to both sides, I will write it in. Normally I don't bother. We would get minus 1 plus 1 is 0, so we get y equals 2x. Negative 8 plus 1 is negative 7. And that's what I found for you before using the gradient-intercept form. So we have those two methods for finding the parallel line. Now we're up to the what? So what? Well, the problem is that you're not always given the equation for the line in this form. And you're not always asked for the result in that form. The equation for a line can be given in a variety of forms. And here they are. We can be given the equation in the form, for example, 2x minus 3, I do apologise, 2x minus y plus 3 is 0. That would be the general form. In the general form we like the x term, then the y term, then the constant, all on one side equal to 0, and the coefficient of x to be positive, and preferably the coefficients all to be whole numbers, integers. So here's our general form. We have this form, 2x minus y is negative 3. Not a very big change, we just move the constant over. This is called the standard form. And these forms have benefits. There are good reasons why we use this one, good reasons for this and this. There's another form, for example, if I divided everything here by -3, I would have negative 2x on 3 plus y on 3 equals 1, and this is known as the intercept form, for reasons I won't go into at the moment. And the list would go on. There are a small number of other forms that mathematicians might use, but these are the more common ones. What if you were given the equation in one of these forms and asked to find the parallel line? That's a bit more difficult, and the classic way of doing it is as follows. We rearrange these into this form. This is the classical method. In fact, I might demonstrate that for you now, very, very quickly. Now, please skip ahead if you're getting impatient with this, but I do want others to understand the process so they can appreciate the shortcut that I show at the end. Let's imagine you're given something in general form. I'm going to make up a different equation. Let's say you've got something like 4x minus 5y plus 11 is 0, and you're asked to find the parallel line, or the line parallel to that, passing through, let's use 4, 1 again. Now, I made this up. We might end up with some nasty fractions or something, but let's see what we get. The traditional method of finding the parallel line is to rearrange this into the gradient-intercept form so we can see what the gradient is. So let's have a look. We want this left alone, so I'll leave the negative 5y here. And I'm going to move the 4x and the plus 11 over to the other side. So I subtract 4x, I subtract 11, then I would divide everything by negative 5. Now, all three of these are negative. If I multiplied through by -1 or -1, everything would become positive. Divide by 5, this becomes y, this becomes 4/5 x, and this becomes 11/5. So this is the form that we aim at traditionally. It's in the gradient-intercept form. We have y equals something x plus a constant. There's our gradient. I'll write the word gradient here. And here's the y-intercept, which is just over 2. 2 1/5, 2.2. That's not so important because we're going to alter that, but we do want a line parallel. So we would say something like, therefore, the parallel line is y equals 4/5 x plus some constant, and we want it passing through this point, so we would get the point 4, 1, or the values, and substitute them into that equation. Let's do that. I haven't got a lot of room, so I'm going to do some steps simultaneously. If x is worth 4, that's what goes here, so let's write that in. 4/5 of 4 plus b. And if y is worth 1, we put that in here. And we've got to solve that. Now, I'm going to solve it this way. I'm going to multiply this 4 by 4, but at the same time I'm going to multiply each term by 5. So 5 times 1 is 5. 4 4s are 16, and if I multiply by 5, it's going to divide the 5 out and leave the 16. And multiplying by 5 will give me 5b. I did that in 2 steps at once to save room. I subtract 16 from both sides, and 5 minus 16 is minus 11. And I divide by 5. So b would equal negative 11 or minus 11 on 5. Goodness, I didn't expect that. The exact opposite. So this becomes our constant, or our intercept, And we would say, therefore, the parallel line, I've run out of room, so I'll write it here. Therefore, the parallel line is y equals 4/5 x minus 11 on 15, 11 on 5. So there it is, the 4/5 x. We needed to find this b, we substituted to find it, put it back in place of b, and there's our result. But we're often asked, if we've been given the question in the general form, then they want the answer in the general form. So guess what? We've got to change that back into the general form. Now, I'm often frustrated by the lack of room on the board. It's just the setup I have here at the moment. So what I'm going to do is put the answer just up here. If I multiplied everything by 5 to get rid of these fractions, I'll get 5y equals 4x minus 11. And if I took the 5y over here, because the 4x is positive, I would get 4x minus 5y minus 11 is 0. And that would be the general form as the result. I want you to notice something. And this is true whether we start with the general form, the standard form, the intercept form, or some other form. We started with this. The traditional method says change it to the gradient-intercept form so you can see what the gradient is. Write the gradient in your new form, new equation. Substitute the point so that you can actually locate where the line is. Find the b value, takes a few lines of work. Put it back in and then rearrange it back from the gradient-intercept form back into the general form. Notice we went from the general to the gradient-intercept, did a lot of work, got an answer in the gradient-intercept form and had to move back to the general form. This is traditional. I want to show you something quite simple and startlingly simple. And before I rub this off, I want to grab my black pen and talk about this equation. When we rearranged this, which numbers were used to find the intercept? Well, you can see it's got the 11 and the 5, so we used that and that. Did the 4 have anything to do with the intercept? Well, no, it didn't. Not at all. Now, that's not the question I was actually aiming at. Let's consider it a warm-up question. Let me ask the very important question. Where did this gradient come from, this 4/5? Well, I think you can see it came from the 4 and the negative 5 here. Now, the sign changed because we had to move something to the other side and we had to do some dividing, but they're the numbers that gave us the gradient. The 11 has nothing to do with the gradient, nothing at all. Consequently, if I'm going to move the line but keep the gradient constant, do you notice that if those numbers give the gradient 4/5, that my answer must have the same two numbers for the same gradient? Have a look at the answer. 4x minus 5y. Doesn't that seem simple? That if this is the stuff that gives me the gradient of the line, then my answer must have the same thing. Now that means that we can actually concentrate just on finding this number in a much more simple way. I want you to watch it. Now I'm going to leave this here. I'll leave this as well, the answer. I'll eliminate this and I want you to see how simple the solution is if you don't have to change it into this form and back. Let's have a look. Well, here's what we do. We write down the equation we're given, we write down the point we're given, and we say to ourselves, we want a line parallel to this one. Now, it's not in the gradient-intercept form, so I don't know what the gradient is. And I don't need to know. If someone asked me, of course I would rearrange the equation. They're not asking that, they just want a parallel line. So, I would say, straight away, therefore, parallel line is 4x minus 5y, that's parallel, plus some constant, I'll use a different letter instead of B or C, equals 0. That line is parallel to that because the 4x minus 5y is the same. And if I rearrange it, I know the 4 and the 5 are the numbers that give me the gradient. So, my question is, if I get the numbers 4 and 1 and substitute, my only job is to find k. Let's check it out. If x is worth 4, which happens to be the front of the equation as well, in this case, I get 4 lots of 4 minus 5 lots of the y value plus k is 0. That's 16 minus 5 plus k is 0. 16 minus 5 is 11 plus k is 0. I'm putting in every step. Subtract 11, k is negative 11. There it is. It's taken about 4 lines of work. We now know the k value, so we say therefore the parallel line is 4x minus 5y, k is negative 11, equals 0. There it is. The chances are very high your textbook hasn't shown you that. Now, there are reasons. When I teach my students and I start teaching them this, of course, I get them rearranging so they can see the gradient, and I teach them the traditional way. But once they've done 10, 15, 20 or 30 of those questions and got the hang of what's going on and they realise we're talking about lines with the same gradient, I then show them the shortcut. Because I say, look, in an examination, if you're asked to find a parallel line, go for it. Don't waste time converting to a different form, solving and then converting back. Save those two conversions and leave it in this form. Just go for it and find the constant. Now this method works regardless of the form that the equation takes. If I will do it. I'll just wipe this and show you really quickly. I won't do a full solution. I'll just show you the process. So, if you're given something in the standard form, let's say 7x minus 2y equals negative 3, or if you're given something like x over 6 minus y over 11 equals 1, or some other form, and you're asked to find a parallel line and leave it in the same format, all you would do, let's imagine I want a line parallel to these through, let's use 4. I'll keep using 4, 1, why not? All you would do is you would write down this part, because it's the x and y values, the x and y coefficients that give you the gradient, and put your constant in place of the other constant and substitute the value. If it was this one, this is my x term and this is my y term, so I would leave it alone, untouched, because I know it's this that when it gets rearranged gives me the gradient, and I would replace the constant. If I was given some nondescript thing, for example, let's imagine x is on one side, 5x, and I had 11 minus 2y. That's not really any standard form that mathematicians use, but if you were given that, then you would simply leave the negative 2y and the 5x alone and replace the constant with a k, because that is going to maintain the parallel line, the same gradient. And all you've got to do is substitute your 4, 1, and you're finished. I'll do it very quickly here. Can't help myself. X is worth 4, so this will be 5 lots of 4. Y is worth 1. So k minus 2 equals 20. Add 2, k is 22. Therefore, the parallel line, now that we know the k value, would be 22, therefore 22 minus 2y equals 5x would be the parallel line. It literally just takes 4 or 5 lines of work. In a lot of ways, I find it a struggle working on video. I like feedback from students, I like to answer questions, and in a class environment I like some exercises to be done so students, if they encounter problems, can ask. Can't do that with you, but I hope that's been of help. And I've got to let you go loose and experiment yourself. Try it out. If this is your current work at school, or if it's something you're going to be examined on shortly, go to the exercise where you've got to find parallel lines, try it out. And you can't really be marked wrong. It's mathematically absolutely correct. If they ask for a parallel line but do not ask for the gradient, this finds the parallel line. End of story. If they say find the gradient as well, then of course you've got to rearrange it into that gradient-intercept form. Simple as that. There it is. End of story. If you've enjoyed it, please leave a comment, please like the video, and I encourage you to subscribe to hear about future videos, including the next one, which will describe how to use this method to find perpendicular lines, which mostly students find much harder. It's actually very easy this way. So I look forward to seeing you in the next video. Thank you for watching.